Well then, we've got some exciting times when it comes to space weather. We've got a massive solar uptick since yesterday. No less than 4 new sunspot groups likely to get named, a number of solar flares, and an incoming coronal mass ejection expected to strike sometime after midday tomorrow on May 10th. We'll be covering that and lots more here at the Smash News Network, least busted name in news. Thanks for stargazing with us as we bring you the most detailed solar imagery and comprehensive daily space weather you'll find in the known universe. This is the past 24 hours from SDO 211 plus 171 angstroms. That's part of the extreme ultraviolet spectrum. And let's get a little closer here. Not too much going on in the southern hemisphere, although there is at least one new sunspot group that just formed right up here. So that one likely to get a name today. It's already Beta Gamma class. There's a little better view of that. Let's take a look at the eastern equatorial region. By the way, the rising of this large sunspot right here represents a major increase in the likelihood of large solar flares. As our regular viewers are well aware, those are more likely to happen close to the limb. So we've got massive sunspots in the Earth-facing zone, some new forming sunspots in the center disk, and no less than 3 groups rising in the east. Rising and or forming in the east, I should say. Of course, most of the activity in the past 24 hours has been in the northern hemisphere. A number of M-class flares. One of M6 plus magnitude. We'll cover that in greater detail later in the video. There is a close-up of the most active region on the closest star. And let's take a moment to look at sunspots here before we get too in-depth. There is the sunspot situation. So first of all, a new sunspot has formed trailing these large groups. So that's the first thing to sight. Right here you'll see a sunspot form. And then there are also 3 more around the eastern limb. So that's exciting stuff. Again, likelihood of solar flares goes up. We've had a major solar uptick in all parameters, like the radio flux. The sunspot number should increase major. Major increase coming today for the sunspot number. 10.7 centimeter radio flux, when we saw it was at 172 yesterday, we thought it might be an error. Nope. That is legit. A number of radio bursts and coronal mass ejections have also occurred. We'll get to those momentarily. First, let's take a moment to see what's going on at Croissant Earth. Welcome to Croissant Earth. Here is what's erupting as far as volcanic activity. Shivaluch, producing an 11,000-foot plume of volcanic ash as it explodes. It's a flight level 110 over Kamchatka. Sakurajima exploding, flight level 070 over Kyushu, Japan. Suminose-jima exploding, 5,000-foot ash plume over the Ryukyu Islands. It's a flight level 050. It's a flight level 050. Pardon that accidental scroll. Luitolo also exploding, flight level 070, 7,000-foot ash plume over the Lesser Sunda Islands. Halmahera featuring Dacono exploding, flight level 070. Popocatépetl exploding in central Mexico, now in the North American region. Flight level 230, 23,000-foot ash plume from Popocatépetl. Go ahead, say it aloud, folks. Popocatépetl. Popocatépetl. You know you want to say it. Santiaguito exploding, flight level 140. Nevado de Ruiz exploding, flight level 210. Revenador exploding, flight level 140. And not sure about Sabancaya in Peru. Unable to detect if it is erupting or not. Next, global seismicity has been quite calm over the past 24 hours. That'll probably make some people on YouTube mad. But yeah, not a lot of quakes and not a lot of big quakes. That's a 90-day bar graph. Here is the past 24 hours. We'll cite quakes over a 5 magnitude, and I think there was only one, a 5.1 at Tonga. That was at 14:14 Universal Time yesterday afternoon. There were some quakes in Alaska there. Again, it's been very calm. Not a lot of quakes, and not a lot of quakes of a large magnitude either for the past 24 hours. If we've missed anything that you would have preferred we cover in this section of the video, or any other section for that matter, please leave us a comment and let us know. We are welcoming of criticism, etc. In science, if you're not admitting that you're wrong, you're probably some kind of a dogmatist. Once again, the 10.7 centimeter radial flux now at 172 solar flux units. There is a one-year chart to put that in context. And we've broken well above this support level of 155 solar flux units. So now breaking back out again here, could it be off to the races? Will we go back over 200 as we've made it all the way up to 234 this cycle? That has been the peak of the radial flux so far. Let us know in the comments what you think about that. Are we going to exceed 200 again in this next week or so? Let's take a moment to look at the Space Weather Enthusiast dashboard. So a long explanation here by NOAA. Quote, rationale, mainly quiet to active levels are expected on the 9th of May, with the likelihood of an isolated early G1 storm period still possible due to the disturbed solar wind field. A return to mainly quiet to unsettled levels is expected most of May 10th. However, CME influences later on 10th May into 11 May are likely to escalate responses to active and G1 storm levels with a chance of isolated G2 moderate storms and slight chance of G3 strong levels. I think we are going to see a strong storm. I think we're going to see a KP 7.66. So that one CME was quite well earthly directed. NOAA doesn't seem to have the model up for it yet, but again, we are expecting a CME impact sometime after noon tomorrow. Later in the day, Universal Time, on May 10th, CME impact. Another one coming, another possibility to see the aurora at mid-latitudes. Wednesday night into Thursday morning. So there's the NOAA model. It has not been updated yet. It does not reflect what they just said in the report. So let's take a look at the NASA model. As this one does indeed show a similar nearly a direct hit here. So part of it is off to the north and west. As you can see in that imagery there, the main core will be off a little bit to the north and west. But we may see some core interactions here, so it could be a great example of seeing solar wind telemetry featuring really three different impacts. Often we see the leading edge, the core of the coronal mass ejection cloud, and then the trailing edge is often a completely different magnetic and plasma environment. So there you go, CME impact coming once again. It's been a banner couple of weeks for space weather. Continuing on to take a look at Earth's magnetic moment from space for the past 4 hours. Things have been calm, although we've had an ongoing proton event as well, as if there wasn't enough stuff to cover. There's been a solar energetic particle event. It looks like it is now subsiding. However, these things could last quite a long time. So polar radio blackouts continuing. They could last for a few more days here. Anyway, that's the last 4 hours of Earth's magnetic moment from space. Our geospace magnetosphere movie depicting magnetohydrodynamic pressure. Here's Earth's magnetic moment from the ground, depicting magnetic flux density at the ground level. And if you're frightened of Earth's magnetic poles reversing, well, you'd see a lot more evidence of that happening in a lot of the different data sets that we cover on our videos. We don't really see that. And a lot of us aren't scared at all of the possibility of a magnetic pole reversal. Last 4 hours of Earth's magnetic moment from space and ground have been calm. KP is only at 1.33. KP 1.33 is the planetary K index and average of global geomagnetism. Next, we'll show the real-time solar wind. Current conditions are pretty unremarkable here, 430 kilometers per second approximately for the solar wind velocity. Solar wind density here about 8.5, about 8.5 protons per cubic centimeter. And let's move on. By the way, that real-time solar wind is measured outside of Earth's magnetosphere out here at Lagrangian point 1, the gravitational equilibrium point where the Sun and Earth's gravity are equal, where you can orbit a spacecraft at very low fuel usage. GOES magnetometers here showing very low highs and kind of low lows for the past day or so. Space weather conditions have been calming down, and keep in mind, folks, it is important to highlight the fact that after you see repeated instances of major space weather, many people believe that the solar system kind of gets swept out, that there's a lot of empty space in there, and you end up getting a better signal. In other words, the plasma sweeps out the other plasma, and you have an emptier solar system, which is a better environment to have major CME or coronal hole high-speed stream impacts. So those are your GOES magnetometers. And next we'll look at the heliospheric current sheet. Now there may be a little acceleration here of the South Pole current sheet. So you may see the South Pole current sheet speeding up in the next couple of days. It's because of that large sunspot in the northern hemisphere that just rose. So don't be surprised to see the heliospheric current sheet showing up as early as midday tomorrow. That's not really going to have too much of an effect on anything, but we just like to cover all of these data points just in case, for future reference, they become relevant to something. As you know, in the realm of science, a lot of times when you immerse yourself in the data, you end up with answers to questions not asked, which is exactly what's happened with the channel. We did not set out to explain the solar sunspot cycles. It just became evident through a process of induction and deduction. And let's take a look at the solar coronal fields, also the photosphere fields. So there is your Gong 2 magnetogram, along with the solar B field depicted in blue lines, north solar polar fields in green, south in red. Again, there could be an acceleration of the South Pole current sheet. A sector boundary crossing is headed your way. Next, coronal holes. And that's what's going on with coronal holes here at the moment. North Pole-oriented coronal holes exclusively on the Earth-facing portion of the solar disk. I will show coronal holes, but first, feast your eyes on that. Shout out to our viewers who like the 171 angstroms wavelength. And here's your coronal holes view. So this is 211 angstroms. This is another 24-hour video. And every single one of those coronal holes is of North Pole orientation, North Pole magnetism. That brings us to sunspots. Again, we'll have 4 new named sunspot groups today. This one will probably be 3,300. And then we'll have 3201, 3202, and 3203. So 3 right there on the eastern limb. Especially this large one up here, very much raising the likelihood of large solar flares. Exciting stuff. Let's take a look at our custom sunspot views. Here's a 24-hour video of the southeastern limb. That spot actually formed, it didn't rise. So right here you'll see this newly formed beta gamma class sunspot. If we show the northern portion, another beta gamma class sunspot forms up here, and a huge beta gamma class sunspot rises right here. Is it beta gamma delta? We'll look at high-res imagery later in the video about that. No major flares yet coming from that northeastern limb. The likelihood of a major flare, like an X-class flare, is like 70% at the moment. And this sunspot has been no slouch in producing solar flares. And next we'll move on to energetic particles, like the GOES proton flux. So there you go. We made it to like 4 or 5 times warning levels there for the GOES proton flux. It's not a major solar energetic particle event, but it is significant. It did cause prolonged, which continued to this moment, prolonged polar radio blackouts as those protons emit radiation and attenuate the D layer of the ionosphere, sending your radio signal to space instead of refracting it back to the ground level. So it looks like it is subsiding here. No new spikes since the last flare activity. And here are the deabsorption region predictions. This is the attenuation of the D layer of the ionosphere. So when you see those equatorial deabsorption predictions, that is a result of solar flares. Those X-rays do not make it below the mesosphere. They're filtered out by that level of the atmosphere. The polar blackouts that you see there in red, those are a result of the solar energetic particle event, or SEP, the Gauss proton flux. So that does cause prolonged polar radio blackouts, as you can see depicted here. And it may be subsiding a little bit here. I'm going to let that play through for my own purposes. So those equatorial perturbations, those are caused by solar flares. And the polar D region absorption is caused by the proton flux, solar energetic particle events. All right, looks like another flare did happen while we were doing show prep. So another M-class flare here. We've had no less than 3 already today, and 4 in the past 24 hours. That's the Gauss X-ray flux. And let's take a look at our 131 plus 94 angstroms, great wavelengths through which to view flares. Keep in mind, this is not depicting X-rays. This is the extreme ultraviolet portion of the electromagnetic spectrum. But these wavelengths take more images. They're specifically designed to view solar flares. And let's get a little closer. Again, the likelihood of a large flare has gone way up with the rising of this. And also the complexity in the Earth-facing portion of the solar disk. We've got several magnetically complex sunspots right in the Earth strike zone, as Tamitha Skov would call it. So these sunspots, again, they've been no slouch. You can see multiple M-class flares there in that imagery. Exciting stuff. And we'll get to coronal mass ejections here in a moment. First, let's orient ourselves. So we've got a setting gibbous waning moon over Lehigh Valley, Pennsylvania. This is, by the way, skyandtelescope.org's star chart. It's the one we currently use. You'll find a million different ones on the internet. I like this one. And if you're up after dusk, make sure you catch Venus, the third brightest object in the sky, and my favorite planet. By the way, if you're one of these Mars fanboys, I'm completely uninterested in the sterile, boring planet Mars. So boring, so sterile, so uninteresting. Almost as boring as Elon's tweets. Which I see even though I don't follow Elon, by the way. Next, a solar system forecast. We've got gas giants on one side and terrestrial planets on the other, but Mercury's about to put an end to that. Here's your 1-week forecast for heavenly bodies. We will have a crescent waning moon by May 16th. And let's move to coronal mass ejections. So again, there was one early yesterday morning. If you want to see more information about that, watch yesterday's daily space weather video. We've been doing it for pushing 6 years now. Just bringing you the most detailed space weather you'll find in the known universe. We do it daily because we discovered that there was a niche that needed to be filled. I had certain data sets I wanted to look at every day, and nobody else was doing it, so here we are. So those were yesterday's coronagraphs. Here are today's 32 additional frames. And do we have any additional CMEs here headed Earth's way? At a glance, I would say no. but I would like some additional reinforcement for that. So let's take a look at the Soho Lasco C2 and C3 together here. We thought one of those CMEs may have an earthly directed component, but maybe not. Let's continue on and take a look at stereo A also. We show this because stereo A is no longer at Lagrange 5. It's right behind the Earth, barely providing any relief in terms of better angular views. We'll show it anyway because sometimes it contains data that is lost. Data that is lost or broken. So anyway, that's keep in mind these frames are not synced. You can see the time and date stamps at the bottom of each one. Stereo A is on the left, Soho Lasco C3 on the right. I am unconvinced that there are any additional earthly directed CMEs. So let's take a look at our custom 24-hour videos featuring 193 angstroms and the Soho Lasco C3 and C2 together and synced. One of the great features of HelioViewer. I'll zoom in a little bit closer here. Definitely some plasma motions happening there. Let's step in one more step here. I'm not sure, folks. I suspect that one of these CMEs may be another earthly directed one. So when we were streaming yesterday, we stated that it looks like one of these coronal mass ejections, this one, the one that comes from this area right here, that may have Earth-directed components as well. So there could be another CME impact on the 11th. That would be sometime after midday on the 11th. So there you go. Another CME forecasted there. And it had to do with, it was associated with all of the events that came from this region. So let me actually go back to this for a minute. Let's see here. Let me go back here. Yeah, I mean, it looks like another earthly directed CME. We're expecting it to show up sometime around midday on the 11th or later. It was a pretty normal speed coronal mass ejection there. And let's get back to look at filaments. We've named some filaments, by the way. This morning we just named filaments after some living people. So we've got 3 huge filaments that just rose over the northeast. There's also one down here that could use a name. But these 3 up here, no need to name those. We've already named them on Twitter. Follow the hashtag #NameThatFilament if you want to name filaments yourself. This one is called the Jerry Seinfeld. This one is called the Larry David. And this one is called the Bill Burr. We've been naming filaments after living people. Shout out to all of our viewers who have. If you haven't followed us on Twitter, what are you waiting for? If you're on social media, you should check out Twitter. Follow the hashtag #NameThatFilament to name solar filaments after living people. Again, that's the Jerry Seinfeld, this is the Larry David, and that is the Bill Burr. We decided to go the comedian route. And let's move on. So here are the past couple of hours, and it looks like a CME is propagating as we stream the video. So this area right here, you can see a huge filament coming out there, and it could be moving toward the GOES 16 SUVI. That does create contrast issues. It's probably too early to see the coronagraphs yet on that. We just showed you the coronagraphs. They are not showing that new CME yet, so we'll be interested to see if that is earthly directed. Wow. Some serious space weather coming at you from the Smash News Network, least busted name in news. And by the way, we are also still in the process of continuing to update and upgrade our systems here. So thanks to the Smash team for that. Let's get to our bonus features segment. We will start out our bonus features with satellite charging hazards. At the moment, it's smooth sailing for satellites. There are no charging hazards. And if you want to follow charging hazards yourself, check out the satellite's community dashboard, one of the many features of the Space Weather Prediction Center. Goes electron flux here coming up off the floor, an indication that the coronal hole high-speed streams are ending. They've been surprisingly weak. Maybe they've been getting canceled out by coronal mass ejections. Keep in mind, solar plasma does have a tendency to interact with other solar plasma. So different regimes may have unexpected effects as they travel through space. That's your GOES electron flux for the past 3 days, which is measured at the F layer of the ionosphere. And if you're familiar with our videos, yesterday's forecast was pretty darn close to exactly where we are. That's the NOAA forecast for relativistic electrons. The green boxes are the forecast and the yellow diamonds are the observation. There is the 1-year chart to put it in context. Back to quite low levels of electron flux here, although that is coming up off the floor. Again, that is measured at the F layer of the ionosphere, so we're going to show that layer, one slice of the atmosphere, the upper thermosphere, in vibrational frequency. That's depicting megahertz, millions of vibrations per second. The gas is very diffuse up in the thermosphere. And keep in mind, folks, each layer of the atmosphere features a temperature inversion. In other words, the troposphere is warmer at the bottom. The stratosphere is warmer at the top. The mesosphere is warmer at the bottom, and the thermosphere is warmer at the top. Each of those layers also features different chemical concentrations, like the stratosphere is primarily ozone, and so on. Once you get to the F layer of the ionosphere at 300 kilometers of altitude, it is basically space. Here's the anomalygram of that same data set. This is anomaly in megahertz from the 30-day median. And only minor perturbations have been happening in the past couple of days here, despite some CME impacts and coronal hole high-speed streams. So nothing too crazy going on in the ionosphere at the moment. Here's the latest image. That's 11:30 Universal Time ionogram and 11:30 Universal Time anomalygram. We also show the total electron content, because this is another set of data that exposes some physics of what's going on in the realm between Earth and space. Space weather can affect your GPS satellite located at 12,500 miles of altitude, so we show the total electron content on the channel daily. These will be the most likely places to see GPS errors, and you should see this getting a little bit more organized in the coming days. Again, the electron flux has now come up off the ground. And if you're not familiar with that imagery, that's okay. We'll show the North American anomalygram for total electron content also. That's anomaly in electron count from the 10-day average. The red dots you see across North America, those are ground stations that use radiography to count the electrons using signal refraction from their known location to satellites with also known locations, obviously. Anyway, there you go. Total electron content. We'll close out the space weather portion of this video with the latest SDO intensitygram and latest SDO magnetogram. First of all, these groups here are beta-gamma class sunspot groups. They are capable of producing X-class flares. And if you think the Earth-facing quiet is caused by human consciousness or some nonsense like that, that is truly ridiculous and idiotic thinking. The Earth-facing quiet exposes some physics about what stars are made of. It has to do with the way metals emit radiation. Metals don't like to emit radiation perpendicular to a flat surface. Why are sunspots dark? It might be controversial to tell you that sunspots are dark because they are flat. Yeah, because they're flat. And hence, we see less X-rays coming from sunspots on the center of the solar disk than we do around the edge. Let me put that in another way. Sunspots that are in this area are less likely to produce large solar flares than sunspots that are outside of that circle. That's what we call the Earth-facing quiet. And it's one of the many reasons why a lot of people think that condensed matter is not only the future of cosmology, but the future of human technology. If you've never heard of superionized materials, I highly recommend you look it up and read about it. Or you could check out our cosmology playlist. Our cosmology playlist has hundreds of videos talking about things like superionized materials, and they're becoming more and more well accepted and understood as time goes on. Things like diamond anvils have allowed humans to simulate some of the high pressure environments that we see in space. Let's take a look at this new sunspot group. It's pretty small. So that'll get a name. We've got a new named group right here that'll get a name. There's a huge group, and there's another group. So 4 new named sunspot groups expected today. Let's take a look at these new rising groups. That one there is Beta Gamma class. That one there is interesting. Could it only be Alpha class? Let's take a look. I suspect it's Beta Gamma class. And indeed, the trailing umbra here is South Pole. So this umbra is North Pole. This umbra is South Pole. It is at least Beta Gamma class. It might be Beta Gamma Delta class. Again, it increases the likelihood of large solar flares. This group here is Beta Gamma class at least. Here's your full disk rock back before we transition to our meteorology segment. Let's take a look at nullschool.net. But first, take a moment to visit the links below the video. Now, we're paid just this side of nothing to put out this content, despite the fact that it is superior to, quote, competitors. There are no competitors when it comes to daily space weather. It's just hilarious that there are channels out there getting paid millions of dollars to spout utter nonsense. One of our missions, and if you want to read our mission statement, you can go to our forum. Our mission is listed right there for everybody to view. smashomash.com/forum/mission. One of our missions is to make America not suck again. Why? Because, well, the best way to get out of a hole is to quit digging. I mean, I'm currently wearing this shirt. Check it out. In the lovely eggplant color. Make America not suck again. Yeah, I'm riffing off of some popular, ridiculous political slogans here. Make America not suck again. Because the best way to get out of a hole is to quit digging. Yeah, quit digging. You can get this design on all kinds of different things. It's designed to be a conversation starter, or maybe even a conversation ender, especially if you know bureaucrats who have been doing their part to make Earth suck again. Let's take a moment to salute. This salute goes out to Admiral Rachel Levine, former Health Secretary of Pennsylvania, now Assistant Health Secretary to the whole country. Rachel's doing a fine job out there, a fine job, making America not suck again, pardon the sarcasm. Links below the video to the merch shop, which features lots more designs that are probably even more inflammatory. Let's go to Earth's weather now. Here is the situation for jet streams of the central world. Yeah, the jet streams of Africa, Europe, and the Middle East. Here are the surface winds. Let's go to the east side. Since they're advanced over there. Yeah, these dudes on this side of the planet are advanced. It's like 12 plus hours ahead of our time here. These are the surface winds for the eastern world, and these are the jet streams. Last but not least, the New World, the Americas. Jet streams are depicted here, and here are the surface winds. Pretty strong low there, right at Newfoundland. Continuing on, let's show clouds and fog. Over these particular continents. So there you go, showing some desolate parts of the world there. The extreme South Pacific. Not a lot of people hanging out in the extreme South Pacific. So that's clouds and fog. Huge clouds there over southern Texas. Well, let's take a look at our weather.gov map. Hydrologic outlooks for Montana. As snow continues to melt, some more snow continues to fall as well. We'll show you some forecasts. There's the key. If your location's lit, head to weather.gov and click your location, weather.gov, the National Weather Service homepage. And here's your total accumulated precipitation forecast based on a GFS model for the next 72 hours. These precipitation totals are listed in inches. And expecting like 5 inches of rain along the Texas Gulf Coast. Also, Nebraska and Kansas going to get some extreme amounts of rain there. And it looks like the drought may be ending in Missouri. Since some of that precipitation will be in the form of snow, here is your GFS 72-hour accumulated positive snow depth change in inches, as it's currently snowing in Idaho. There's also some significant snow here coming to Colorado, the land of hot air, Wyoming, California, Oregon, Montana, and even some showing up in New Mexico. Let's move on to our pressure and precipitation forecast. There's going to be a strong low that forms over eastern Colorado and then moves up to the northeast. That's your GFS 72-hour pressure and precipitation forecast. And let's continue on into uncharted territory. Heavy lightning here around southern Texas. That's your NASA GOES lightning mapper. And let's check for terrestrial strikes, courtesy of lightningmaps.org. Quite a bit of lightning here across the U.S. The most activity is southeast of San Antonio. Dag! That is a severe thunderstorm indeed. Look at the lightning. That is berserk. I can't even read the name of this town. Hey, Victoria. There's thunder rolling in, to say the least. That could be producing damaging wind, hail, even a tornado. So please heed your weather warnings. Severe thunderstorms, one of the few things that stop a bike race from occurring. Almost nothing stops a bike race from occurring. Severe thunderstorms are one of them. Next, you're invited to support the channel via clicks. SmashOmash.com is the homepage. You can find us all over social media at SmashOmash. You'll find the Hemp Lucid shop, the Amazon, the brand new Amazon affiliate shop, now open for business. If you want to know what supplements we take, spices, you can buy spices in bulk via our links. Also some office furniture, like if you're looking for a set of 6 bunker tubs for your bunker, you can find some great bunker tubs. We use them ourselves. Maybe we'll even do a product review of our bunker tubs. We're even writing a song about it with our brand newly formed band, Devil's Dander. Yeah, for our debut LP, called fish scale. Anyway, continuing on, and welcome to the Neo Renaissance. Please support the channel via the links below the video. If you'd like to see the videos continue to exist and remain publicly visible and free for all to view, we need your help, not just to get them onto screens, but to support the channel financially. An affiliate/sponsor link also is the Hemp Lucid link, so check that out. If you're shopping at hemplucid.com, make sure you enter the promo code SMASHOMASH to save some dough on checkout. All kinds of different products there for various different things, whether it's sleep, or for focus, or for better skin, or for perhaps immune response. Hemplucid.com, enter the promo code SMASHOMASH to save some dough on checkout. And if you want to support the channel via subscription services to get some additional content, consider becoming a member of the Smash Team at smashomash.com/Smash Team. We launched it back in October of 2021 because we needed superior capabilities to Patreon, and now we have them. Give Smash staff a raise by becoming a member of the Smash Team. As again, we're paid just this side of nothing to put the most detailed and comprehensive space weather and solar imagery in the known universe onto YouTube. Press the share button, comment, etc. if you're unable and or unwilling to open your cobweb-encrusted wallet. And just so you know, email alerts even go out to the bronze level at the Smash Team, thanks especially to the gold annual paid-up subscribers. And to gold and silver level Smash Team members, we'll close out the video with another plug to the Amazon shop. Amazon.com/shop/smashomash, or visit the links on the homepage or below the video for those lists. And those will be expanding, so stay tuned to that. And let's take a look at snow depth, as there is still plenty of snow, despite all of that hot air coming out of Colorado. Colorado, the new hot air capital of the U.S. It used to be Hawaii, or perhaps Florida, or maybe Texas. Now Colorado, creating global warming with the massive carbon footprint of ultra-rich hack frauds occupying the state of Colorado. Scott McIntosh not included. Lots of snow. Expect epic melt season to continue. There's a long way to go to melt all of that snowpack. Next, we've got U.S. Doppler radar. And don't worry, folks. We've got more than U.S. Doppler radar. We're also going to show you the clouds and fog scenario over the U.S. And we're going to show you the water vapor map. Just give me a moment to initialize that this video was streamed live originally, by the way. If you weren't aware of how these work, these videos go live on Twitch, where they are exclusive live streams. And then they become exclusive YouTube videos. So if you don't catch them live on Twitch, it's too late. By the time the video ends, it's already too late to catch it. So here is your final series of data sets to perhaps improve your understanding of Earth and space weather, starting with U.S. Doppler radar, clouds and fog. That's 3.9 micrometer radiation, by the way, part of the infrared spectrum, the NASA GOES Interactive Weather Satellite Suite. And there is the water vapor map. You can see that moisture being held in place. It's surrounded by dry, massive air there, which is corralling that moisture and not allowing it to move up to the northeast. That is why those storms might be moving in odd directions if you're in Texas. Here's a recap. U.S. Doppler radar. Clouds and fog. And there is water vapor. Anyway, thanks for tuning into the Smash News Network, least busted name in news. Again, don't forget to press like, subscribe, share, etc. Leave us a comment, whether derogatory or nice. It's not going to hurt our feelings, and we'll see you soon with another live stream. In the meantime, may that solar wind be at your back.